find all x-intercepts and y-intercepts of the rational function, or state that they do not exist. Write the intercepts as ordered pairs. All right, the first thing we want to do is take a look at the rational function in factored form. So the numerator factors as x plus 2 times x plus 2. You can check that by FOILing this out. You'll see that it's x squared plus 4x plus 4. And the denominator, greatest common factor, factor out the x, and we have x plus 3. The nice thing about the factored form is you can see what makes the numerator 0. You can see what makes the denominator 0. Now when it comes to a rational function, you do not want the denominator to be 0. That would be dividing by 0. So that would happen at 0 and negative 3. Those, in fact, x equals 0 and x equals negative 3 are the equations of the vertical asymptotes. But the numerator can equal 0, and if the numerator equals 0, and that happens at x equals negative 2, then the whole fraction is 0. So notice, if x equals negative 2, f of negative 2 would be 0 times 0 over whatever it is. I guess it's negative 2, but it's 0. So that means that this, in ordered pair form, is the x-intercept. Now for the y-intercept, you plug 0 into the function. And because that creates a divide by 0, there is no y-intercept. State they do not exist. So we would say y-intercept d does not exist. So we have one x-intercept, and the y-intercept does not exist because x equals 0 is not in the domain of this rational function. Now, had you factored the numerator and denominator and had been able to reduce a factor, what that would do is it would decrease the x-intercept that reduced, unless it's somewhere else as well, and it would decrease the vertical asymptote, but instead it would create a hole. Whatever made that equal 0 would be a hole. That might come up later on in the questions for you. Okay, so this is how to find x and y-intercepts of all functions in general. X-intercept, set y to 0 and solve. Y-intercept, set x to 0 and evaluate. Writing in ordered pair format is the most common form. All right, hope this helps.